Every year, thousands of vehicle owners make critical motor oil mistakes that cost them a fortune in repairs. And by the end of this content, you will discover the secret that experienced mechanics use to identify defective oils before they completely destroy your engine. The statistics are alarming. Approximately 15% of all serious mechanical breakdowns originate from incorrect lubricant selection, and the most surprising thing is that many of these problems are completely preventable with proper knowledge. My experience of more than 20 years in mechanical workshops has taught me that most drivers are unaware of the risks they face when choosing the wrong oil for their vehicles. The first devastating mistake I constantly see is using cheap conventional oils in engines that specifically require advanced synthetic formulations. These economical oils may seem like a smart option to save money, but the reality is that they lack the specialized additives that protect internal engine components under extreme temperature and pressure conditions. When you use inadequate oil in a modern turbocharged engine, like those found in many current European vehicles, you are exposing the turbo bearings to temperatures that can exceed 400 degrees Celsius. Without adequate protection, these components degrade rapidly, and the cost of replacing a turbocharger can easily reach £2,500. But here comes the most shocking part. I have seen cases where owners of premium vehicles used low-quality oils for just 6 months, and the result was a completely destroyed engine that required a complete rebuild worth £8,000. Non-detergent oils represent a silent threat that many drivers severely underestimate. These archaic products were designed for engines manufactured before 1960, when filtration systems were primitive and manufacturing tolerances much wider. Using non-detergent oils in modern engines is like sending soldiers into battle without protective armor. The absence of cleaning agents allows combustion residues, metallic particles, and contaminants to accumulate on internal engine surfaces. This gradual accumulation forms varnish-like deposits that obstruct the smallest oil passages, especially in variable valve timing systems and hydraulic actuators. The cost of professionally cleaning these deposits can reach £1,200, but if the obstruction causes damage to critical components like camshafts or pistons, you are looking at a repair bill that can exceed £6,000. Additionally, these oils lack anti-foam additives, which means that under high engine speed conditions, the oil can fill with air bubbles that severely compromise its lubricating capacity. I have documented cases where sports engines have suffered catastrophic damage to main bearings due to cavitation caused by foamy oils, resulting in repairs exceeding £15,000. If this content is helping you avoid these costly mistakes, I invite you to subscribe to the channel and activate the notification bell, because I regularly share automotive industry secrets that can save you thousands of pounds in unnecessary repairs. The second critical mistake involves incorrect oil viscosity, and this is particularly dangerous during winter months when temperatures drop significantly. Oil that is too thick in cold conditions behaves like frozen honey, unable to circulate properly through narrow engine passages during the first minutes of operation. During this critical period, which can last up to 3 minutes in below-zero temperatures, metallic parts are operating with virtually no lubrication, causing wear equivalent to hundreds of kilometers of normal driving. Turbocharged engines are especially vulnerable to this problem, as the turbocharger can spin at more than 100,000 revolutions per minute, even during idle. Without adequate lubrication, turbo bearings can reach temperatures of more than 500 degrees Celsius, causing microscopic deformations that eventually result in catastrophic failures. Conversely, oil that is too thin cannot maintain its protective film under high pressures and temperatures of normal operation, especially in high-performance engines. I have documented cases where sports engines have suffered catastrophic piston damage due to using oils with inadequate viscosity, resulting in repairs exceeding £12,000. The phenomenon known as lubricating film breakdown occurs when oil cannot maintain an effective barrier between moving metallic surfaces. This condition results in direct metal-to-metal contact, generating excessive heat and accelerated wear that can destroy an engine in minutes under high load. Modern multi-grade oils are formulated with viscosity index improvers that allow adequate cold flow while maintaining necessary protection at high temperatures. Ignoring these specifications can result in problems like piston ring seizure, especially in direct injection engines that operate with extremely high combustion pressures. API classification is another fundamental aspect that many drivers completely ignore, and this oversight can result in serious emission system problems. Oils with obsolete classifications like APISG or earlier do not contain the additive packages necessary to protect modern emission control systems. These systems include advanced catalysts, particulate filters, and extremely sensitive oxygen sensors that can be irreversibly damaged with inadequate oils. Oils with more recent API specifications like SN+ or SP contain reduced levels of zinc and phosphorus, elements that can poison modern catalysts. The cost of replacing a damaged catalyst can reach £3,200, not counting additional expenses for sensors and other exhaust system components. Vehicles equipped with emissions post-treatment systems like diesel particulate filters or selective reduction catalysts require oils with specific low-ash formulations. Using oils with high ash content in these systems can cause obstructions that require professional cleaning worth £1,500 or more. A common trap I frequently observe is premature use of oils specifically formulated for high-mileage vehicles. These oils contain seal conditioners and special additives designed for engines that already show signs of wear. Typically after 150,000 kilometers of use, seal conditioners work by slightly swelling rubber and elastomer materials to seal small leaks that develop naturally over time. When used in relatively new engines, these additives can cause seals to swell excessively, creating leaks that did not exist previously. I have seen cases where owners of vehicles with just 50,000 kilometers have caused leaks in the main crankshaft seal, resulting in repairs costing more than £1,400. Additionally, these oils contain more aggressive viscosity modifiers that can cause sludge formation in engines that have not developed the internal deposits typical of high-mileage vehicles. The paradox is that a clean engine can be compromised by oils designed for dirty engines, creating problems that did not exist originally. Uncertified recycled oils represent another significant risk that many drivers severely underestimate. Although the concept of recycling is environmentally responsible, recycled oils that do not meet rigorous standards can contain microscopic contaminants that act as abrasives inside the engine. The proper re-refining process requires sophisticated vacuum distillation techniques, treatment with special clays, and addition of completely new additive packages. Low-quality recycled oils may retain traces of heavy metals like lead, cadmium, and chromium, elements that can cause accelerated corrosion on internal engine surfaces. These contaminants can include microscopic metallic particles, combustion residues, and other elements that gradually destroy internal engine surfaces. Without proper certifications from organizations like API or ACA, these oils represent a risky gamble that can result in damage worth several £1,000s. Properly processed recycled oils can be just as effective as virgin oils, but the difference lies in the quality of the refining process and certifications that support the final product. Using oils designed for diesel engines and gasoline vehicles is another costly mistake I see with alarming frequency. Although diesel oils contain higher levels of detergents and anti-wear additives, their specific formulation is not compatible with gasoline engine emission systems. Diesel oils typically contain between 800 and 1,200 parts per million of zinc, compared to 600 to 800 parts per million in gasoline oils. The high zinc and phosphorus content in these oils can poison catalysts, causing premature failures that require costly replacements. Additionally, these oils do not burn cleanly in gasoline engines, which can result in carbon deposits on valves and combustion chambers. Direct injection systems are particularly vulnerable to these deposits as they can cause pre-ignition and detonation that damage pistons and valves. I have documented cases where prolonged use of diesel oils in gasoline engines resulted in severe carbon accumulation that required professional cleaning worth £1,200. Generic unbranded oils represent one of the most underestimated threats to engine longevity. These products frequently lack consistent quality control, using inferior base oils and inadequate additive packages. The oil industry uses a classification system for base oils ranging from Group 1, most basic, to Group 5, full synthetic. Generic oils frequently use questionable quality Group 1 or 2 base oils, which do not provide the thermal stability necessary for modern engines. Without verifiable certifications, you are literally playing roulette with your vehicle's heart. I have documented cases where generic oils broke down after barely 3,000 kilometers, causing severe sludge formation that required professional engine cleaning worth £1,000. The lack of adequate antioxidant additives in these oils can result in rapid acid formation that corrodes internal engine surfaces. Quality oils use phenolic and aminic additives that prevent oxidation, but generic oils frequently omit these critical components to reduce costs. Now let me debunk some dangerous myths that continue circulating among drivers and can cause significant damage. The first myth is that commercial oil additives always improve engine performance. The reality is that modern oils already contain carefully balanced additive packages by specialized engineers. A typical oil contains between 15 and 25% additives, including detergents, dispersants, antioxidants, viscosity index improvers, and friction modifiers. Adding additional products can alter this delicate balance, causing problems like excessive oil thickening or interference with emission control systems. I have seen cases where commercial additives caused oil passage obstructions, resulting in inadequate lubrication and damage worth several £1,000s. Molybdenum additives, popular in aftermarket products, can cause problems in wet clutch systems and automatic transmissions if used incorrectly. Another persistent myth is that only manufacturer-branded oils are suitable for your vehicle. The truth is that any oil meeting the required technical specifications will provide adequate protection. Automobile manufacturers do not produce oil, they simply specify the standards it must meet. Brands like Mercedes-Benz, BMW and Volkswagen have their own specifications, MB, BMW L, VW, that must be met, but multiple oil brands can satisfy these requirements. Many times, the official brand oil is produced by the same companies that manufacture oils for recognized brands, just with a significantly higher price. The price difference can be 50 to 100%, without significant differences in quality or protection provided. A particularly dangerous myth is that milky or foamy oil is not cause for concern if the engine runs normally. This condition generally indicates coolant or water contamination, which can be a symptom of serious problems like head cracks or head gasket failures. Milky oil can also indicate excessive condensation, common in vehicles that make frequent short trips without allowing the engine to reach its optimal operating temperature. Ignoring this warning sign can result in catastrophic damage requiring complete engine rebuilding. I remember the case of James, who ignored milky oil in his BMW for 2 months and ended up paying £4,500 for a repair that could have been avoided with early intervention. Coolant contamination can cause emulsion formation that blocks oil passages and compromises lubrication of critical components. The myth that synthetic oil causes leaks in older engines also needs to be definitively debunked. Modern synthetic oils do not cause leaks, they simply reveal them if they already exist. Their greater flow capacity allows them to filter through seals that were already deteriorated, but leaks were being disguised by thicker oils. Synthetic oils have more uniform and smaller molecules that can pass through micropores that conventional oils cannot traverse. This early revelation is actually beneficial as it allows seal repairs before they fail completely. Synthetic oils also provide better protection against oxidation, longer change intervals and better performance at extreme temperatures. Finally, the myth that changing oil type creates a permanent commitment is completely false. You can alternate between synthetic, conventional or synthetic blend oils according to your needs and budget. Synthetic and conventional oils that meet the same specifications are completely compatible and can be mixed without problems. The important thing is to always use oils that meet the specifications required by your specific engine. The key is maintaining consistency in quality and specifications, not necessarily in the specific brand or type of oil. To select the correct oil, always first consult the owner's manual, which specifies exactly the required viscosity and classification. The manual will also indicate if your engine requires special specifications like low ash oils or specific formulations for post-treatment systems. If you do not have access to the manual, the oil cap frequently shows the recommended viscosity engraved directly on the metal. Many European manufacturers engrave these specifications on the oil cap, including specific codes like VW 50400 or BMW L04. Dealers and specialized stores can also provide this information based on your vehicle's chassis number. Modern databases allow identifying exact specifications simply by entering the vehicle's VIN. Warning signs of inadequate oil include unusual engine noises, especially metallic sounds or knocking during startup. These noises can indicate inadequate lubrication of main or connecting rod bearings, a condition that can result in catastrophic damage in minutes. Irregular idle, cold start difficulties and increased fuel consumption are also indicators of oil-related problems. Inadequate oil can cause greater internal friction, which translates to power loss and reduced efficiency. When the engine warning light comes on, especially if it flashes, stop the vehicle immediately and check the oil level and condition. A flashing light frequently indicates critical lubrication problems requiring immediate attention. Regular oil monitoring through monthly visual inspections can prevent costly damage. Oil should be checked with the engine cold and the vehicle on level surface to obtain accurate readings. Look for changes in color, consistency, or presence of metallic particles on the dipstick. Healthy oil should maintain its characteristic color and flow smoothly without forming lumps or foam. Oil that has turned completely black or contains visible particles should be changed immediately. The presence of metal shavings can indicate serious internal wear requiring professional diagnosis. Oil change intervals vary according to oil type, driving conditions, and manufacturer specifications. Full synthetic oils can last up to 25,000 kilometers under normal conditions, while conventional oils typically require changes every 10,000 kilometers. Severe driving conditions like frequent short trips, driving in extreme temperatures, or use in dusty conditions may require shorter intervals. Vehicles equipped with oil life monitoring systems use sophisticated algorithms that consider multiple factors to determine optimal change timing. These systems analyze oil temperature, engine revolutions, engine load, and other parameters to calculate oil degradation. However, these systems cannot detect fuel or coolant contamination, so regular visual inspections remain important. Oil temperature is a critical factor that many drivers completely ignore. Oils operate optimally in a specific temperature range, typically between 80 and 120 degrees Celsius. Excessively high temperatures can cause thermal decomposition of oil, while too low temperatures can result in inadequate lubrication. Turbocharged engines are particularly sensitive to oil temperatures, as the turbocharger can raise oil temperature significantly. It is crucial to allow the engine to cool gradually after intense driving to avoid oil carbonization in turbo passages. The correct procedure includes letting the engine idle for 2 to 3 minutes before shutting off after aggressive driving. Proper oil storage is also fundamental to maintaining its quality. Oils should be stored in cool, dry places away from direct sunlight and heat sources. Exposure to extreme temperatures can alter oil properties even before use. Open containers should be sealed hermetically to prevent contamination and oxidation. Oil that has been stored incorrectly can develop sediments or viscosity changes that compromise its effectiveness. The manufacturing date should be verified before use, as even unopened oils can degrade over time. Synthetic oils generally have a longer shelf life than conventional ones, but all oils eventually degrade during storage. The environmental impact of oil selection also deserves consideration, as higher quality oils typically result in fewer changes and less waste. Long-lasting synthetic oils reduce the total amount of oil discarded during the vehicle's lifetime. Additionally, high-quality oils can improve fuel efficiency, reducing the vehicle's CO2 emissions. Conscious choice of certified oils and responsible brands contributes to more sustainable environmental practices. Proper recycling of used oil is equally important, as a single liter of oil can contaminate up to 1 million liters of water. Professional workshops and auto parts stores frequently accept used oil for proper recycling. Now that you know these professional secrets, you can protect your investment and avoid unnecessary costly repairs. Prevention is always more economical than repair, and intelligent oil selection can significantly extend your engine's lifespan. Remember that your vehicle is one of the largest investments you will make, and oil is relatively cheap compared to repair costs. The difference between an economical oil and a high-quality one can be 20 pounds, but the difference in protection can be worth thousands of pounds. If this content has been valuable to you, subscribe to the channel and activate notifications to receive more professional tips that will help you keep your vehicle in perfect condition for many years, because every week I share advanced techniques that normally only the most experienced mechanics know.